everyone, and welcome to this video going over the Unit 4 study guide. In this video, I will be going over most of the problems for your Unit 4 study guide in order to prepare you for your upcoming test. So let's get started. We started this unit with going over properties of exponents. So in number 2, we have 2m times 2m to the power of 3. When you have more than one variable or some coefficients, make sure you treat everything separately. So I'm going to do 2 times 2 because those are my coefficients, and I'm going to do m times m to the power of 3. 2 times 2 is 4, and when we don't see an exponent, it's an imaginary 1. And when we multiply with exponents, we add the exponents together. So 1 plus 3 will give me m to the power of 4. And so altogether, my answer is 4m to the power of 4, which would be D. In number 4, I have 2a to the power of 4, b to the power of 0, all to the power of 3. When you see parentheses being raised to a power, make sure the exponent goes to everything, even that coefficient. So we will have 2 to the power of 3, a to the power of 4 to the power of 3, and b to the power of 0 to the power of 3. Notice how everything gets the exponent. 2 to the power of 3 means 2 times 2 times 2, which is 8. And when we raise a power to a power, we multiply them together. So 4 times 3 is 12, and 0 times 3 is just 0. And remember, anything to the 0th power is just 1, so I can remove that b to the power of 0, and I'll be left with 8a to the power of 12, which is A. Moving on to number 6, we have 3a squared divided by 4a to the power of 3. I'm going to treat the 3 over 4 separate from the a's. And when we divide with exponents, we subtract them. So this is going to lead to 2 minus 3, which is negative 1. And remember, in order to get rid of a negative exponent, we put it in our denominator. So I will have that 3 over 4, and I will have 1 over a to the power of 1. When I combine those, I'll be left with 3 over 4 times a. In number 8, once again, if I have parentheses raised to an exponent, I have to make sure that everything gets the exponent. So this will be 2 to the power of 2, u to the power of 2 to the power of 2, and v to the power of negative 1 to the power of 2. 2 to the power of 2 means 2 times 2, which is 4. When I raise a power to a power, I multiply them together. So this will be u to the power of 4. And negative 1 times 2 will get me v to the power of negative 2, which I need to send to the denominator because it's a negative power. And this will leave me with 4 u to the power of 4 over v to the power of 2, which is C. Last one, number 10. Once again, if I raise a power to a power, I multiply them together. So this leaves me with x to the power of 8 over 2x to the power of 3. But I can keep simplifying since both of these have a base of x. When I divide with exponents, I subtract them. So 8 minus 3 leaves me x to the power of 5, and that 2 is still in the denominator. There's no reason why that 2 would have come up to the numerator. It stays in the denominator with that x to the power of 5 on top. And so that is a review of our properties of exponents. After we talked about exponents, we started talking about adding, subtracting, and multiplying polynomials. So let's move on to question 12. And when we add polynomials, and you know that you are adding because there will be a plus between your polynomials, all you have to do is combine like terms, which means you are looking for variables with the same power. In this case, I have 2 and 3, which are just constants. 2 plus 3 is 5. And I have a negative 4b squared and a positive 3b squared. Because they both have a b squared, they are like terms, and negative 4 plus 3 is negative 1b squared. Now please practice writing your answers in standard form, which means the highest exponent needs to go first. So I am going to flip these around, and this will be negative b squared plus 5. Now adding polynomials is very similar to subtracting polynomials, but there's one extra step. So when you see a minus between the polynomials, you need to distribute the negative to the second polynomial, which means we are multiplying every term in that second polynomial by a negative 1. So the first polynomial stays the same. Negative 1 times 4n squared will be negative 4n squared, and negative 1 times negative n to the power of 4 will be positive n to the power of 4. And then we combine like terms. So I have 4n to the power of 4, and n to the power of 4, and negative 2n squared, and negative 4n squared, which will leave me with 5n to the power of 4, and negative 2 and negative 4 combine to negative 6n to the power of 2. Let's try this again. So once again, I have a negative, which means I'm subtracting, and I have to distribute this negative to every term of that second polynomial. So the first polynomial will stay the same, but the second polynomial will turn into negative 3n squared, negative 4n to the power of 4, and negative 5n. And then I combine like terms. I have a 7n squared and a negative 3n squared, a 2n to the power of 4, and negative 4n to the power of 4, and that negative 5n doesn't have any like terms, so it'll stay as it is. I'm going to start with my n to the power of 4s because that's the biggest exponent. 2 and negative 4 will combine to negative 2n to the power of 4. 7n squared minus 3n squared will be positive 4n squared. And then I can't forget that negative 5n. Now that we've reviewed adding and subtracting polynomials, let's talk about multiplying polynomials. When you multiply two polynomials together, your choices are to FOIL or use the box. With the box, you need to make sure that every single term has its own slot, and then we are multiplying the column label by the row label. So for this first box, I am multiplying 2a times 7a, which will get me 14a to the power of 2. In the box to the right, I am multiplying 2a times negative 2, which will get me negative 4a. In the bottom left box, I am multiplying 6 by 7a, which will get me 42a. And in the last box, I am multiplying 6 times negative 2, which will get me negative 12. After you complete your box, you look to combine like terms. But remember, when you combine like terms, you are adding. So I know at first we were multiplying to fill out the box originally, but after the box is completed, you add to combine like terms. So I have a 42a and a negative 4a, which will combine to 38a. And then I have that 14a squared out in front, and that minus 12 at the end. Let's try this again. In number 20, I have a binomial times a trinomial, which means I need to make a bigger box so that every single term has its own slot. And then I multiply. X times 7x squared is 7x to the power of 3. X times negative 6x is negative 6x squared. X times 1 is just x. And now I'm on the second row. 5 times 7x squared is 35x squared. 5 times negative 6x is negative 30x. And 5 times 1 is 5. I now need to look to combine like terms. I have negative 6x squared and 35x squared, and x and negative 30x. So my final answer will be 7x to the power of 3, 29x squared, negative 29x plus 5. And that was multiplying polynomials. Next, we moved on to talk about factoring. Our first factoring technique that we talked about was factoring by the greatest common factor. So in number 21, I am looking for the biggest term that divides 56b to the power of 5 and 64b to the power of 4. Well, I know that 8 will divide both 56 and 64, so 8 is part of the greatest common factor. But notice how both terms also have some b's in common. I want to know how many b's can I take out from each term. So you always look for the smallest exponent because both terms need to cross out the same number of b's, and so you have to look at the smallest exponent to determine how many you can take out from both of them. So each term can cross off 4 b's from their total. Once you identify the greatest common factor, you then divide by the greatest common factor. So 56 divided by 8 is 7. And when you divide with exponents, you subtract them. So 5 minus 4 is 1. And then the next term. 64 divided by 8 is 8. And when you have a b to the power of 4 on top and a b to the power of 4 on the bottom, those will cancel out, leaving me with just that 8. And then I'm going to go ahead and write the greatest common factor on the outside. Let's try this again. In number 23, once again, I'm looking for the greatest common factor. Now notice how that constant term does not have a b attached to it, which means we are not going to have any b's in our greatest common factor. But I do know that each of these terms can divide by 2. And so 2 is my greatest common factor. 10 divided by 2 will be 5, with that b squared. 18 divided by 2 is 9, and 8 divided by 2 is 4. And I always need to remember to write the greatest common factor on the outside. Now that we've factored with the greatest common factor, let's practice factoring with our magic X. So let's look at 25. I label A, B, and C. And notice how there is no number in front of p squared, which means we are going to use our regular magic X, where we put c on top and b on the bottom. C is negative 10, and b is 3. And so I'm thinking of two numbers that multiply to negative 10, but add to 3. So two numbers that come to mind for me are 5 and 2. But one of them has to be negative in order to get to negative 10. And to add to 3, positive 3, I'm going to make the 2 negative. And because this is the regular magic X, I already know what my binomials will be. This will just be p plus 5, because I had a positive 5, and p minus 2 for that negative 2. So that is the regular magic X. Let's see how we use the modified magic X. Looking at number 27, always, always, always look to factor out a GCF if you can first. Like I see that I can divide each of these terms by 2. When I do that, I will have 3v squared minus 20v plus 25. I still have to write the 2 on the outside. And now I can use magic X. I have A, B, and C. And because there is a number in front of v squared, I have to use my modified magic X, which tells me I need to multiply A times C. So 3 times 25 will get me 75. And B still goes on the bottom. So I put negative 20 on the bottom. I need two numbers that multiply to 75, but add to negative 20, which tells me both of my numbers are going to be negative. And so the two numbers I can think of are 15 and 5. And because this is the modified magic x, I need to put my a value on top. So I'm going to put 3 on top of both of my numbers and simplify if I can. So simplifying 3 and negative 15, I get 1 over negative 5. And 3 over negative 5 cannot be simplified. So the number on top tells me what goes next to v. So this will be 1v minus 5 and 3v minus 5. Still with that 2 out front because I divided by it in the beginning. So please make sure, even when it says you are going to do magic x, look for a greatest common factor first. Let's try this again looking at number 28. In number 28, it does not look like I have a greatest common factor because 17 is prime. So I'm going to go ahead with my magic x. I need to multiply a times c for the top, which will be negative 18, and then put b on the bottom, which is negative 17. And two numbers that I think of that multiply to negative 18 and add to negative 17 are negative 18 and 1. I also have to put the a value on top and simplify if I can. 3 over negative 18 can simplify to 1 over negative 6. And this tells me that my binomials will be n minus 6 and 3n plus 1. The number on top tells you what goes next to your n, and the number on bottom tells you what you are adding or subtracting. Let's move on now to talk about parabolas. In 29 and 30, we are identifying the x-intercepts, the vertex, and the domain and range. So let's start with 29. Our x-intercepts are where we cross the x-axis. And so it looks like I cross the x-axis in two places, at negative 4 and 2. And remember, the y value for both of these values is always 0, because on the x-axis, the y value is always 0. And so your x-intercepts will be negative 4, 0, and 2, 0. The vertex is the point where the U is formed, so at the curve. And so it looks like my vertex is negative 1, negative 9. Make sure to name it as a point with your x going first and your y going second. And now let's talk about domain and range. Remember, domain is left to right. So because I have these arrows here, it looks like I will be going to the left forever and to the right forever. And so we say that our graph is going from negative infinity to positive infinity. Because if you notice, on the left-hand side, the x values are getting negative, so that will be negative infinity. And as we go towards the right, the x values are positive, and so that would be going towards positive infinity. For the range is low to high, and so it looks like my graph goes as low as negative 9, and we're going to use a bracket for that, because notice how I have a solid point there. And then my parabola goes up forever. So that will be negative 9 to positive infinity. Let's do the same thing with 30. For 30, once again, I have two x-intercepts at negative 10 and negative 2. My vertex is where the U is formed at that curve. And so it looks like my vertex is negative 6, negative 16. And then once again, I have arrows on the sides of my parabola, which means I'm going to the left forever and to the right forever. And then my range. I go as low as negative 16, and then I go up forever to positive infinity. Our last problem, we are going to see how, given a quadratic function, we can graph the parabola. So it says start by factoring. This is my regular magic x because there is no number in front of the x squared. So 7 goes on top and 8 goes on the bottom. I know that 7 times 1 is 7, and 7 plus 1 is 8. So my factored form will be x plus 7 and x plus 1. In order to identify the x-intercepts, I am looking for where my polynomial is 0. So I'm going to set each of my binomials equal to 0 and solve each individually. I'm going to start by subtracting 7 to both sides. And this tells me that one of my x-intercepts is -7. And then I'm going to subtract 1 from either side. And this tells me that my other x-intercept is -1. Now that I know the x-intercepts, I am looking to find the vertex. The vertex occurs in the middle of my x-intercepts. So I'm going to start by adding the two together and dividing by 2. -1 plus -7 is -8. Divided by 2 is -4. So I know that -4 is the x value of my vertex. And to find the y value, I need to plug in this -4 into my function. So my function is here at the top. So I will say -4 squared plus 8 times -4 plus 7. And you can plug this into your calculator. But -4 times -4 is positive 16, because when I multiply two negatives together, it gives me a positive number. 8 times -4 is -32, plus 7 will give me -9. So my vertex is at -4, -9, and my two x-intercepts are -7 and -1. With these 3 points, I am ready to graph. My two x-intercepts are at -1 and -7, and my vertex is at -4, -9. And this helps me sketch my parabola.
And lastly, we're going to practice our difference of squares pattern. In order to factor completely, make sure that you look to see if you can factor out a greatest common factor first. So for example, in 32, it looks like I have a greatest common factor. I think I can divide both 80 and 45 by 5. 80 divided by 5 will give me 16 with that k squared. And 45 divided by 5 is 9. Don't forget to write the 5 on the outside. And now notice how I have my difference of squares, because 16 and 9 are both perfect squares. The square root of 16 is 4, so I'm going to have 4k, and the square root of 9 is 3. So my factored form will be 4k plus 3 and 4k minus 3. Don't forget that if you factor out a greatest common factor, that it will still be on the outside. And let's try 34. Both x squared and 16y squared are perfect squares. The square root of x squared is x, and the square root of 16y squared is 4y. So I will have x plus 4y and x minus 4y. And there was no greatest common factor, so there is no number on the outside. I hope that this video helped you get a good start on your Unit 4 study guide. Please let me know if you have any questions, and I'll see you in class.